The history of man may be far longer and stranger than we think. The Great Pyramid may indeed not fit in with what we believe about the past and the nature of the world. Thousands of years ago, someone measured the earth with remarkable accuracy and recorded this information in the dimensions of the largest and possibly the oldest stone building on the planet. William R. Fix. Generally, the age of the pyramid is given around 4,200 years, roughly about the same age as the Sphinx. Some of you are probably familiar with the redating of the Sphinx by several geologists, primarily Robert Schoch from Boston University, who has studied the weathering of the limestone composing the Sphinx and the surrounding quarry that the Sphinx is situated in, and has determined that the rock has been severely weathered by water erosion. And of course, the Giza Plateau has been desert for the last 4,000 years, so it's not likely you're going to find severe water erosion on the Sphinx if it's only 4,000 years old. In fact, so severe is the water erosion that it's likely that the Sphinx is probably tens of thousands of years old. However, Robert Schoch, in most of his public presentations, usually places it at 7,000 to 9,000 years, but he's told me personally he just uses that because he's deliberately being very conservative because he's in the academic community, but he's perfectly willing to believe that it could be much older than that. And I've discussed the extent of the water erosion with him and discovered that he actually hasn't looked in depth at the comparable studies of rates of limestone weathering, which I spent a couple of months about 10 years ago studying, going around to various places where there were limestones and where you could see examples of limestone that had been weathered, and had looked at, read the literature that had been done on limestone weathering, and had concluded that, you know, it would be a minimum of 20,000 years worth of weathering. And that's a minimum if you took the Sphinx and set it in a climate with rainfall, like say we've been having for the last 3 months, which would average out to about 45 inches a year. Even with rainfall like we've been seeing here in Atlanta in the last 3 months, it would take the Sphinx a minimum of 20 to 30,000 years to get the level of erosion. That raises the question regarding the Great Pyramid. Could it be as old? And I see no reason why not. Problem here, though, is you know that the Great Pyramid was once covered in white limestone casing stones, highly polished, and according to Arabic traditions, pretty much all the Arabic traditions and legends about the Great Pyramid concur that the outside of the pyramid prior to the stripping of the casing stones was covered, completely covered in hieroglyphs. And it just boggles one's mind to contemplate what might have been written there. But clearly, I have a hard time imagining a greater act of vandalism in all of history than the stripping of those stones. In fact, there had been efforts to get into the pyramid up until the time of Al-Mamun, which was, I think, around 1200 AD, but they were completely ineffectual. And then somewhere around the 12th century, I've forgotten the exact year, there was a great earthquake in northern Egypt, and it caused most of the buildings in Cairo to collapse, and it also loosened some of the casing stones on the pyramid, which allowed them to get in and pry those stones loose from the top. And all of the stones were then stripped off, and that indurate high-quality limestone was stripped off and recarved and used in buildings to rebuild Cairo. So I've often thought there's probably temples somewhere in Cairo where maybe some of those original stones are still to be found with inscriptions intact. Of course, I have no idea, but I've oftentimes thought, wouldn't that be cool? Anyways, they stripped off the stones, and as they stripped them off, there was a lot of rubble that fell down and buried the bottom of the pyramid, which turned out to be a good thing because it buried the bottom casing stones from those and preserved them. And so from those, you know, the various researchers could determine what the original exact angle of the pyramid was. And according to most calculations, it was around 51 degrees, 51 minutes, 14 seconds. I don't know if that level of accuracy is credible or not, but 51 degrees, 51 minutes would be. And from there, we can then determine what the geometry of the pyramid would have been and what its original height would have been simply by taking the tangent of that angle, 51 degrees, 51 minutes, and knowing the base length, one could calculate what the original height would have been to a high degree of accuracy. So that's been done by, 4 or 5 different people over the years. J.H. Cole in 1925 did what's considered to be the definitive survey of the Great Pyramid. He was a professional surveyor who did a very meticulous survey after they had just cleared away all of the rubble, and he had access to it. He did it under contract to the government of Egypt. The numbers that I'm about to show you here are mostly derived from his survey. So what we have here is here's some of the original casing stones, and they sit on what's called a socle, which is this base, which was measured to be 55 centimeters in thickness. And of course, you got to bear in mind that this original slope casing stone, it wasn't stepped like that originally. It was a smooth profile. And okay. So here you have, of course, here you see that the casing stones were damaged by the rubble falling down, but enough of them were still intact that one could make this accurate determination of the original angle. Here's the socle, which is 55 centimeters thick, and it sits directly on bedrock. So it actually, what it does is it creates 2 ways that one could measure the height of the pyramid, either with or without the socle. There's also 2 ways of measuring the base. This is a reconstruction from 1991 work on pharaonic stonemasonry. And this shows that outside the corners, which was the core masonry, there are these sockets. And I found one picture showing a socket. This is showing one of the sockets that's still there, that sits outside the core masonry. But based on those sockets, they were able to reconstruct what the original base of the pyramid would have looked like. So here would have been the 51 degrees, 51 minutes, coming down, sitting on the 55 centimeter thick socle here, like this. Well, what this did was it gave 2 ways of measuring the perimeter of the pyramid's base. One could be measured from this point up on top of the socle. The other could be measured from down here that included the socle. So what you ended up with was 2 ways of measuring the pyramid's base. Well, which one was the correct one? Well, they were both correct. I think that they were actually intending to embody in there that there were 2 ways of measuring the pyramid's base. So what we have is the length of the base on the socle, which is the shorter of the 2 up there. It was varied from side to side. You'll notice 755 at the smallest to 756 just over at the largest. So there was some variation. There was probably a reason for that variation, actually, but we won't get into that because it just gets too technical for what we're talking about today. But the total of those measured around the 4 sides would be 3,023.139 feet. If you're taking notes, that'd be a good number to write down. Okay, so now let's see what the measure is around that includes the socle, or the base. And we see that each side is roughly 5 feet longer, 760 to 761. Each side, again, is a little different, but we get a total of 3,043.433 feet. Okay, so I'm going to, over here, I'm going to write down a few numbers that we saw through our radius of the moon, diameter of the moon, radius of the sun, diameter of the sun, number of seconds in a day would be 43,200. Number of seconds in a half a day, number of seconds in a full day, 86,400. What were some of our other numbers? Oh yeah, 1440 was one, 7920. Diameter of the earth, just so they're up there in front of you, we can refer to them as we go on here. All right. So here is profile the Great Pyramid with a 51 degree, 51 minute angle. To make it easy, I've just rounded off the numbers, 481 feet in height. That would be not including the socle, the base. 755.85, I just picked one to use. And And there's our 51 degree, 51 minute angle. And we find that when we measure it this way, it turns out to be almost exactly 11/7. There's some other interesting geometry going on related to the golden section, which I don't intend to get into today because it makes more sense if you're actually studying sacred geometry and you're familiar and you've made these drawings. Because in a sacred geometry class, just like in the old Pythagorean and Platonic lodges, we draw, and then we eventually build models. And that's the way to really get familiar with this and get these numbers as part of your consciousness. So I'm not going to get into the connection with the golden section today. When we measure, including the socle, this becomes our height, 482.7575 feet, and the base, 760.9 feet. Okay, those are the numbers we're going to look at for a second here now. If we look at these are various estimates. We're looking at this one right here, the coal height estimate plus the socle at 21.6 inches gives a total of the height above bedrock of 482.7575 feet. So now we're going to go back to the Earth so we can see how these numbers link the two. We take 1 square degree of latitude and longitude at the equator. Pretend we're standing at the equator. Okay, we know that the polar radius now is 13 miles less than the equatorial radius. So what that means is that the circle this way is shorter than the circle. The biggest circle that defines the Earth is the equatorial circle. So a degree of measure on the equator is going to be the biggest, the longest of any degree we measure anywhere on the Earth, the equator. Okay, the north-south is going to be a little bit shorter. And you'll notice right there, we've got 68.7 miles north to south and 69.17 east to west. So it's not a perfectly square unit, is it? It's a little bit distorted. Well, that distortion is totally significant because it's that distortion that is a measure of the Earth's departure from being a perfect sphere. And it's that departure of a perfect sphere that is very significant to us, because without that, again, Earth's orbital stability would be non-existent. Okay, so we're going to divide this up a little bit. If we take this square degree of latitude north to south, longitude east to west, and we look very carefully down in the lower right-hand corner, you're going to see something, a little square. You see that little square? That represents 1 minute, 1/60th of the degree this way, 1/60th of the degree this way. So that's 1 minute of latitude and longitude, all right? We're going to take a closer look at that, and we will see that 1 minute then is 6,045.881 north to south, 6,087 east to west, which is what we expect. The east-west should be a little bit longer, and that's 1 square minute of latitude and longitude. Okay, now we're going to divide each of those lengths into 2. We're going to divide our square minute into 1/4 sections. And here's what I want you to notice. When we do that, we take 1/4 of a square minute of latitude and longitude. Look at our dimension east to west, and look at our dimension north to south. And look at these two numbers. In fact, here's an accurate calculation. We take the 482.755 feet, which is the height, and what we discover is that if we multiply that by the number 43,200, which is one of our sacred numbers that we've seen right there, 43,200, it shows up in the Vedas and the Sumerian king lists, etc., etc. If we multiply the height of the pyramid by that number, this is what we come out with, 3,949.83 miles. And notice the difference between the pyramid, which I call the standard polar radius, and World Grid System 72 is only 313 feet over the entire size of the Earth. So we have essentially the pyramid being a scale model of the Earth, the northern hemisphere, at a scale of 43,200 to 1. If we take the pyramid, enlarge it by 43,200, its height, including the socle, now becomes the polar radius of the Earth within 300 feet of our satellite surveys. And the two measures of the base are exactly the difference between the east-west difference and the north-south difference at a square minute at the equator. Now, the skeptic and the reductionist would dismiss this and say, it's just a coincidence, you're just playing with numbers. And I would say, okay, you can believe what you want, but it's there. The numbers are there. You can take the surveys of Egypt by Cole, you can take the geodetic surveys. I didn't make those numbers up, or I didn't fudge them. And what you discover is that when you expand it by 43,200, which, if the number was just some arbitrary number, but it turns out that the factor of expansion turns out to be one of the critical sacred numbers within the ancient systems. And so here we have the pyramid now enlarged by 43,200 times. And another way to think of it is if we go back to this diagram right here, you'll see that as the Earth turns, every half second, it's going to turn this far. So it means that every 2 seconds, the Earth, if you're standing on the equator, in 2 seconds, the Earth has turned 143,200th part of its total orbit. So if you're standing on the equator, in 2 seconds precisely, the Earth has turned a distance exactly equal to the distance around the base of the Great Pyramid. Now you can dismiss that as being coincidence, but the numbers don't lie. They're there. And so when William R. Fix was saying that someone somewhere thousands of years ago was able to measure the Earth with great precision, and I haven't, of course, elaborated upon all the details of this. I'm trying to give you the overall picture of how it might have worked.